This part, let's focus on the neighbor establishment and route calculation. So for the neighbor establishment, actually, we will relate it to the 7 neighbor states, okay, and the 5 packets. So actually, the packets we have introduced before include the hello, dbd, lsi, lsu, lsack. So for the 7 states, as the neighbor states include the down, init, two-way, extart, exchange, load, and for. So for the 4th stage is the final stage for the OSPF neighbor relationship. Okay, so now let's learn the more details about the neighbor establishment. And for the first process, between 2 routers, we can see the topology here. And in the topology, we have R1, R2, 2 routers. And for the R1, the route ID is 1.1.1.1. For the R2, the route ID is 2.2.2.2. And the R1 has a segment information is 172.16.1.1. Okay, is the interface IP. And of course, the R1 has the 10.10.10.10, the net mask is 22, and the 178.16.1.0, this net mask. Okay, and for R2, the R2's interface IP is 172.16.1.2, and the segment information has the 10.10.10.10 and the 172.16.1.0 and the 172.16.1.10.0. These 3 segments. Okay, so for the 2 routers want to exchange the RSA information and want to build the neighbor relationship, and then go to the 4 states. So which the process and which the neighbor relationship states we have to go through. So first is the down status. Okay, the down status. So after we do the router OSPF, like the process ID set 1, and set the route ID information, right? And the route ID information is the 2. And then network the RSA information into our network, right? Network. Include all the segments on the R2. Of course, the same operation is on the R1. We also have to do the root OSPF process ID and the root ID and network all segments on R1 device. So after this, and the R1 R2 never exchange any packets. Now the status is done. Okay, so we can see in the R1 neighbor table, the neighbor table is none. No neighbor ID information, no neighbor address information, no neighbor status information. Okay, and then the R1 wants to build the neighbor relationship between R2. So the R1 will send the hello message. So the hello message, actually, we know the function is to establish the neighbor relationship, maintain the neighbor relationship, and elect the DR, BDR, their other, and so on, right? So now, first we have to send the hello message. So the hello message actually includes the root ID information. So here is the message concept. The my root ID is 11111, and I don't know anyone in the network yet because now I haven't built the neighbor relationship between any routers. So now the R2 receive this packet, right? Receive this packet, and the R2 will add the R1's information from the hello packet to the neighbor table. And for the neighbor table, we add the neighbor ID information, neighbor address information. So the neighbor ID actually is 1.1.1.1. And then the neighbor address is 178.16.1.1 because the IP address of the R1 is this IP address, right? And we add this 2 info into the R2 neighbor table. Okay, and then the R2 will become next status is the init status. Okay, to receive this hello packet, so the R2 also had to send the hello packet, and now the R2 send the hello packet includes the information. One is the root ID information, two is the neighbor ID information. So when the R1 received the hello packet, so the R1 will know my neighbor is a 2.12.2 and my neighbor has my root ID information. So it means the R2 think the R1 is the R2's neighbor. So now the R1 will add the R2's root ID into the neighbor table. So the neighbor ID is 2.12.2 and the neighbor address is 172.16.1.2. So this is the IP address about R2, right? And then I will change my current status into two-way, okay, into two-way, because I want to know the R2 sync I and the R2's neighbor. So two-way actually is the neighbor relationship status, but the two-way actually is the first kind neighbor relationship, and the two-way is actually is the neighbor relationship between the dear other, okay, between the dear other device. So we can see for the first process, the neighbor discovery by hello message, and we use the hello to find the neighbor. And then we will record the neighbor information into our neighbor table. And then the second is the send hello message every 10 seconds to maintain neighbor relationship more than 40 seconds is considered as feature. So what does this mean? It means between the two router, right? And we will build the neighbor relationship. After we build the relationship successfully, and we have to keep the neighbor relationship. So every 10 seconds, we have to send the hello packet. So R1 will send to R2, R2 will send to R1 every 10 seconds. Every 10 seconds, we have to send the hello packet, keep the neighbor relationship. And after this, maybe sometimes R1 and R2 or the link between the R1 and R2 doesn't work normal. Maybe some problems, some error happens on R1 or R2, right? So the R1 or R2 won't send the hello message to each other. So now, if the time is more than 40 seconds, actually it's 4 times to the hello time, right? It's 4 times to the hello time. And during the 40 seconds, we can't receive the hello packet from each other. So maybe the R1 can't receive the R2's hello packet. So we will break down. We will break down. So if the R1 want to talk with the R2, so the R1 need to build the neighbor relationship again. Okay. And next is a two-way state at this point cannot exchange link state information yet. So it means the two routers build the relationship is a two-way state. And for the two-way state, the two router can't exchange the LSA information. So it means the R1 can't learn the segment information from the R2. The R2, of course, can't learn the topology or the network information from the R1 because now the R1 and R2 just build the relationship to be the two-way, not the four state. So now we can't exchange the LSA information between each other. Okay. So which the state we can exchange the link state actually is the four. But for the different router, actually we have introduced the different rules of our router. First is the DR and second is the BDR and the third is the DR other. Actually we know the two-way state is built between the DR other and the DR with the DR other and the BDR with the DR other will build. The relationship is the four, right? So it means the DR other won't exchange the link state between each other. Okay, after this, we can see the neighbor relationship establishment. Here is the two routers will send the hello to each other and build the neighbor relationship. And then every router will add the router's ID and the IP address of this link into the neighbor table. Of course, I will change the status, right, from the down or inlet and the two-way. So actually the two-way is the state of our two routers for neighbor relationship. Okay. And next we will go on to next status. So here two routers have built the neighbor relationship successfully. So now, after we built the neighbor relationship, what happened? So R1 wants to send a message, right? So R2 also wants to send a message. So now, which router sends the message first? Which router sends the message follow another router? So this is the problem we have to solve, right? So now we are ending to next state. So this state is the start. Actually, the start is for the routers to choose which is the master, which is the slave. So the master means I will send the information first. The slave means I will send the message after the master. Okay. So now the R1 and R2 want to choose which is the master, which is the slave. So R1 first send the DBD message. So the DBD message we have introduced is actually include the LSA head information, right? And for here, the R1 sends the DBD message, and it means I started to exchange information because my root ID is 11111. It means I am the master. I will to send the information first. Okay. After this, and the R2 also sends the DBD message. For this DBD message, actually, it means I will start exchange information first because my root ID is higher than yours. So what does this mean? It means my root ID actually is a 2.2.2, right? And I want to send the information first because your root ID is a 11111. I am higher than yours. So I am the master. Okay, I am the master. So this is the election for master and slave. Actually, the R1 want to be the master and send the packet to the R2. And when the R2 receives this packet, he also sends the packet to R1 and includes the information I am the master because my root ID is higher than yours. So you are the slave. So now the status is start. It's a start. Okay. So after we exchange the DBD message, we have to send the useful information, right? We have to send the useful information. So the useful information actually is the DBD message. So for the election, the master and slave, the DBD message doesn't include any useful information, just for to choose which is the master, which is slave. So here we can see for the R2, because R2 is the master device, so the R2 have to send the information first. So the message is also DBD, but this DBD message is included the detailed information, and the information is the RSA header information, right? So maybe the DBD will include this segment, this segment, this segment, of course, this segment information into DBD message. And then this is the summary information of my linked state database. Of course, after the R1 received this message, he had to send the DBD to R2. And the DBD message includes all the segment information here into the DBD message. So this is the RSA header, okay, header, not the detailed RSA information. So actually, this step is for two routers to compare which RSA I have and which RSA I don't have. So after this, our status will become the exchange. And now we can see when the R1 received the DBD message and the R1 find, I have the 10.10.10.10 and 172.16.1.0, but I don't have the 172.16.1.10.0, this segment, right? And I find I don't have this segment, so I want this segment. How to get the segment? So I will send the LSR message, and the R1 will send the LSR to request this segment, right? So I need your complete information about the 172.16.10.0, this network. Please give me. And the R2 receive this LSR message will answer the LSU message. Actually, we know the LSU includes the detailed LSA information, right? It's a detailed information into the LSU message. And for the LSU message, we'll include the 172.16.10, this network. And when the R1 received this packet, the state will become 4 because the R1 has the whole segment or the whole information about this network. Okay. After this, the R1 will reply the LSACK. We know the LSAK used to reply the LSU message. And the LSACK message is the I received it, thank you for the information. And the R2 will receive this packet, and then we finished all the packet exchange. So now if we check the neighbor relationship on our device, we can see the current status is the 4 status. Okay, so the 4 is the correct status for our router to build the neighbor relationship between each other. Okay. So next we can see for every router, after we build the relationship as the two-way and we ending to the next status, to the start, exchange, load, and for. And for the load and the for state, we will exchange the LSA information between each other so that we can add the LSA information into LSDB. And then every router will have the whole LSA information and have the complete LSDB, right? And then we will use the SPF algorithm to calculate the LSDB, get the root table. So this is the neighbor relationship establishment process. So we will relate the 7 stages from the down innate two-way and to the start, exchange, load, for. So the final status for the 2 routers is a 4. So we have to use the show IP OSPF neighbor, this command, to see the neighbor relationship. Make sure the neighbor relationship is a 4 state. This is correct. Okay. And next, and for this page, we will introduce the OSPF state machine. Actually, here in this page, we see the down init two-way start exchange node 4. The 7 state we have introduced, right? And for the 7 state, we will meet this status during the OSPF neighbor relationship and to exchange the RC information, right? So now we will learn the more details about every state. So except the 7 states on this page, we also can see the new state, right? Is an attempt. This is attempt. So actually the attempt is the special state for just the NBMA mode. So now if the mode is broadcast, so in the broadcast we don't have the attempt this state. So the attempt state is special for the NBMA. Okay. So actually the attempt means to send a hello packet to our neighbor but does not receive any info. Okay. And the down in it, we know we enable the routers into the OSPF process. So we haven't sent and we haven't received any packet from the neighbors. So now the state of our router is the down. So the down means does not receive any hello packets from the neighbors. So from the down to init or the attempt to the init, we have to send the hello packet. We send the hello packet and then the router receive the hello packet. Maybe the hello packets don't have the neighbor list. So when we receive the hello packet from the neighbors, but the hello packet don't have the root ID information about our neighbors. Okay, so now the state will become the innate. Will become the innate. So this state indicates that the neighbor does not receive the hello packet sent by the local router. Okay. And next is the two-way. So two-way actually we know it's the status between two routers, means we have built the neighbor relationship successfully. Actually, your neighbor table has my route ID information, has the IP address information, and my neighbor table has yours. Neighbor relationship includes the route ID, includes the IP address information. So the two-way state actually is established a neighbor relationship in two directions. So we can find the route ID in hello packet, and then the neighbor will know my neighbor's route ID and add the route ID into the neighbor table. Okay. And completes the DR and BDR election in the multi-access network for this step. And next step is a two-way to the start. We know the start actually is to choose the master and slave, right? And to choose which router can send the packet first. So for the start, we exchange the DPD packet. The DPD packet actually doesn't include any RSA information in the DPD packet. We just use the DPD packet to choose which is the master, which is the slave. And next step is the exchange. So for the exchange, actually, we also have to send the DPD packet, but this DPD packet includes the RSA list or the RSA header. So for tutors to exchange the RSA header, and we will know which RSA I have and which RSA I don't have. So this is the DPD function. And from exchange to the load, for this step, I will know which RSA I don't have. So I have to send the LSR to request the RSA I don't have, so that can complete my LSDB. And for the load, I will send the LSR packet to request the RSA information. And then the neighbor will reply the RSU packet. So for this state, the RSU will contain the detailed RSA information. So this is the loading. Okay, so from the load to 4, actually, we finished all the RSA start, exchange, right? And then every router have the 4 or have the complete database. So now we can see the X state here, the attempt, init, start, exchange, and loading. This state is the OSPF intermediate transmission state, and the down two-way 4 is the OSPF stable state. It means our neighbor relationship can maintain to be down two-way 4. Actually, the two-way is the routers as a rule of the DR other. So the DR other actually maintains the neighbor relationship as a two-way, and for the DR to DR other, BDR to DR other, will maintain the neighbor relationship as the 4 state. So this is the OSPF state machine. And next, for this page, we will learn the 3 stages in OSPF adjacency establishment. So before we have introduced during the neighbor relationship, we have two kinds of the neighbor relationship. One is a two-way, second is a four. So the two-way actually means the neighbor establishment, and the four state it means the adjacency establishment. And in two-way state actually we just can send the hello packet to each other, but we can't send the RSA information, we can't exchange the RSA information between each other. And for the adjacency, actually the two router can send the RSA information between each other and build the complete RSDB, right? So this is the differences between two kinds of neighbor relationship. So for the first, the neighbor discovery and the neighbor establishment is a two-way state. For the two-way state, actually, we use the hello packet to discover our neighbor, to establish our neighbor, to maintain our neighbor. Okay, so this is the neighbor relationship. So for this state, actually, we established a neighbor table. In the neighbor table, we can see the root ID information, see the IP address information, see the neighbor list information. Okay. So after one router has the neighbor root ID, so the state of this router will become the two-way state. So it's very simple for two routers become the two-way state. And next, the neighbor relationship is the adjacency. So for the adjacency, we have to exchange the detailed RSA information, and we use the DBDE, RSR, RSU, RSCK to complete or to send the RSA information between each other. So during this progress, we will use the DBD, RSR, RSCK, RSU, these four packets to exchange the RSA information. So after this, all routers in the area have completely the same RSDB information. So this is the second neighbor relationship, is the adjacency. And next, we can see for three comments. The three comments is a show IP OSPF neighbor to see the neighbor table, and show IP OSPF database to see the RSDB, and show IP router to see the routing table. So for the three table, actually first two routers have to establish the neighbor relationship between each other. And then after this, we find the state is the 4, right? Is the adjacency is the 4. And it means we have finished all the RSA information exchange. And then we can use the show IP OSPF database to see the detailed RSA in our RSDB. We can see the link ID, we can see the segment information, the age, and the advertisement, router, sequence number, checksum. Okay, except this, we also can show IP router to see the routing table. So for the database to the routing table, actually we have to do the router calculation. So each router performs the SPF calculation independently of RSDB complete. So it means every router has the complete RSDB, and then for this RSDB we will use the SPF to do the calculation, and then we will have the routing table. So add the calculated optical router to the routing table. So maybe from the source to destination, we have the different ways to through, right? And every way has the different priority. So we have to compare this parameter so that we can choose the best way and add this best way to the routing table. So for the routing table, actually, we'll store or we'll show the best way for us to transfer the packet from every source to every destination. So this is the three tables. Okay, three tables. So this is the neighbor establishment